Hello, intrepid coders. We are here in the third part of this little series called Persisting Redux State to an API. So if the title and the thumbnail and that intro doesn't give it away, this is the third part in this series. So if you haven't checked out the other videos, I do recommend you at the very least check out the first video, because that is where I build a starting point that has a create React app up and running, a Node Express server up and running, and to save our state to and to retrieve it from, hence the API part. And it's where I talk about how I coded out the Redux toolkit stuff to get to the starting point. So the boilerplate, if you need this, will be in the description below, as well as the previous two videos. So check those out if you want to see how I built this thing. And then the second video is a cool solution, and then today is another solution that will actually utilize a specific library, and one that one of my students went to immediately, called redux-persist. It seems like it would get the job done, and it even has tons of additional plugins or wrappers around it to create custom storages. We'll get into some terms here in just a minute. I'm actually pretty new to this particular library as well, so integrating it wasn't too terrible, and getting it working with just local storage, which is not the purpose that the student, or the question that my student had that spawned this entire series, is very, very easy to get working with local storage. It basically just serializes or JSON stringifies your entire state, stores it in the browser's local storage under a certain key, and then retrieves it and hydrates your store upon a page refresh or page visit or something like that. It's actually very, very simple how it works, and we're going to take advantage. Yeah, here we go. We're going to take advantage of that and not utilize some of its features. And it took me a hot minute to get to a solution that worked for using an API. So, you know, I actually poked around several of these. Like, you have it for React Native, especially with its async storage and its Expo file system and things like that. You can even use it with session storage, Electron storage. I've seen a lot of like Stack Overflow posts with individuals asking how to use this with Electron apps and things like that. So node storage just basically builds up a directory that it stores anything into a file for us. It's very, very simple how it works. I looked it through some of these and their source code to figure out what bit I was missing, because we're going to be taking advantage of this one right down here, the custom object. We can make any object or a class, whatever you like to do, as long as it has the following methods: set, get, and remove item. And these methods must be supporting promises, right? So you can use promises inside of them and return them that way asynchronously. That's the whole point of this thing. So we're going to be using an object with these three properties. And again, there wasn't tons of good. I realized my green screen's kind of acting up on me there, but whatever. Looks good enough for government work. Yeah, we're going to be using this custom object and taking advantage of this library to try and see if we can getting and posting to our API, just like we did as our goal in the other two videos before this one. So yeah, let's just install this sucker, get everything up and running on the boilerplate, and we'll be good to go. I've already got it cloned and ready. Remember, I was poking around in it earlier. I'm going to need two windows here, one for my server and one for the create React app itself, since it also runs a server on its own port. Okay, so npm run server was the command I had for running my lovely little Express server, and then we're going to npm, actually no, we're going to do npm I, kind of need the library here, don't we y'all, for redux-persist. Install that, npm started afterwards, and we're good to go. So I'm talking about, y'all. Okay, and hopefully opens the browser here. Make sure everything, I like always making sure all my boilerplate stuff always works. We have a full stack boilerplate for a React client, an Express backend that's not create React app, like we rolled our own. And I always, whenever I show students a demo on it, I always have to install and run it fresh to make sure something hasn't broken on it, or me or my co-instructor Andrew, who's posted videos on our channel as well, hasn't managed to accidentally push some changes to the boilerplate repo that we didn't mean to, and we have to do some git commands to revert things. You know, it's always fun when that happens. Anyway, looks like we're up and running just fine. There is no saving feature at the moment. Looks like I have a typo in the boilerplate itself. This should be count/add. I mean, let me zoom in on that. This is a incorrectly named piece of state for these actions here. I don't know why the action is auth-add when it should be count-add. I like how I'm like, this boilerplate's sick, and I proceed to have a typo in it that I never caught until the third video in this series. Brilliant. All right, typos abound. If you remember that from the previous video, I think typos are kind of my thing, right? I think that's what's being illuminated here. Anyway, we have redux-persist now installed, and let's go ahead and get it up and running as simple as possible. So, you know, you'll see solutions online and Stack Overflow posts, posts and some blogs and things like that from years prior when people were using redux-persist and just vanilla Redux itself. But redux-toolkit actually has some stuff configured into its store, some like, I think some linting check-ins. I mean, it has tons of clearly middleware already applied in configureStore. I talk about more of this in my React course. Check out the links below if you are interested in taking that, or just joining our Discord and asking some questions and interacting with us. I always like questions because it makes great content for YouTube. But like I said, like I was trying to say, configureStore, it has a lot of middlewares and other things already added to it, and it has some rules and linting and warnings and error handling configured inside of it that will end up giving you some trouble with redux-persist out of the box. So we actually need to do is configure a store, and we need it to also get its current list of middleware from the configured store, and then we need to tell it that there is a particular property called serializable check, meaning it will attempt to look through our objects to make sure they can be serialized, aka is it a proper format of an object to be able to be swapped to, say, like a JSON string. Because if it's not serializable, then it's going to tell you that's probably not a good idea, because you're setting something to state that we can't technically handle or save or like reproduce correctly, right? So it has these built-in checks. We need to tell it to ignore certain ones that come from redux-persist. So we're gonna get there in just a moment. Let's just see if we can just kind of follow the docs and get this up and running, because there's a couple of steps now we have to introduce with redux-persist. So, all right, this is my default code. So I'm gonna do redux-persist stuff right underneath it. Surprise, surprise, we're gonna be importing some things, or several things, from redux-persist. We need something called a persist store. That is going to be the store that we create that ends up having the store version that is persisted that we're going to be passing to a component later on. We're going to need to create a wrapping, and this is kind of like what I did in the last video, right? In the second part of this series, where I made like some kind of wrapping reducer around our rootReducer that allowed me to do like cool calls to this, passing in custom actions, so I can hydrate the store in a cool fashion. And I think I haven't looked at the source code for this, but I imagine it probably does something kind of similar, right? So we need that, those two right there, and we're also going to eventually need some kind of storage system for redux-persist. Like I said, it has built into it by default the usage of local storage, but again, it is not simply configured for you out of the box. So we're going to be importing storage from redux-persist library / and I believe it was just storage. Yeah. So this storage file just has some code in it with an object that had those same keys, get item, set item, remove item, built into this object here for us, and it will allow us to configure our store with this local storage. We're gonna get it working there and try and kind of figure out our way around it from there. So okay, so redux-persist needs to have some kind of configuration object. Their documentation, you'll see something called persist config. It's going to be a vanilla.js object we're going to assign some values to. We're going to say there's a key. You can call this root or primary. I actually haven't done too much digging around into the naming of this key. I know you can have like nested and multiple persisted reducers. So I imagine the key kind of tells you, in case you're nesting these persisted reducers, which one you're looking at or is firing this action, right? You can do even versioning control with this as well, and it has some built-in features into Persist Store. I haven't personally messed with it quite yet, but I'm actually, it quirked my eyebrow, and I'm quite interested in messing with it in the future, after this video rather, where there's some cool versioning you can do. So say, hey, if this is version 1 and we have a new structure of our Redux state that's version 2, it'll actually take a persisted version 1 and help you, and it has, I think, 3 different functions to merge the states together to kind of help you add features that will, over time, as you keep adding more slices to your app, that's pretty cool that it has kind of like merge functions like that. I like that a lot. And here is the key we really care about, which is storage. And if we just assign it to the value storage, ES6 shorthand, we can just do storage : storage like that. But I'll be changing the variable later. So for now, I know if people like shorthand are yelling at me. We're going to leave it like that for now because I'll be changing this value later. But that's the simplest I believe the persist config object needs to be. And this is, again, just configuring our persisted store. And there's other properties as well. Again, I had to take more time to keep digging through their documentation. This video's purpose is not a full-length deep dive on redux-persist. It's more of how can I get this up and running and calling to an API, which is, again, the original question the student had a question. That's redundant. That's the original question the student had that led this whole discussion and journey and fun times and webinars in Discord. So we're going to now create our persisted reducer, that wrapping one I was talking about. It's going to be a call to persist reducer. The first argument will be our config object, persist config. Our second one will be our apps reducer. We're going to be wrapping with our root reducer there. Wunderbar, that's what I'm talking about. So now, here's where things get a little bit weird, right? I need to, well, I mean, let's just see what happens vanilla before I talk about this. Let's just see what happens now. If I do export const, we'll call a persister. This is like our persisted version of the store. It's going to be a call to persist store, and we're going to pass our configured store into it like that, just vanilla style. I think this is what their docs even look like, right? And this reducer here should also be our persisted reducer. That actually makes a bit more sense. I was looking at this variable, wondering why it was dimmed out, and I was like, there we go. I was looking at that variable in VS Code, persisted reducer, and I was wondering why it was dimmed out, and I was like, why? What? Oh, because I didn't, I forgot to put it there. So this is like as bare bones as we can get. Now, just like with redux-toolkit having a library that connects them somehow to React, because again, this is just vanilla JS code we're dealing with here, there is also some code that we're going to be having to add to our index file here. At the highest possible level of our app will be some other code as well. I'm going to import not only store but also our persister from that store file, because we need to have that imported here. And then also from, surprise, surprise, not React Redux, but redux-persist has its own little built-in integration folder as well that gives you some components to wrap your app with and handle the persisting logic. And it is called, surprise, surprise, the persist gate is the name of the component in this newest version. Because again, that's something else I ran into, is looking at like overflow posts and blog posts even from a few years ago. Evidently redux-persist had like a lull for a while where it wasn't getting a lot of updates, and you see a lot of stuff on V4, V5. I should probably mention this at the beginning of the video where I am on V6 of the latest install. Okay, so from here, I'm going to wrap my app in our persist gate component, just like we do with our store. Wunderbar, there we go, yeah. And this thing has two props that you're going to be utilizing out of the gate. One is called loading. You can pass in any kind of custom loading component you want, or just null if you don't want anything to be loading, meaning if the state is taking a minute to retrieve from our server, whether you're on a bad mobile connection, our server just happens to be slow that day, or something like that, then this loading boolean, or it takes a React component, will kick on while it's trying to hydrate the store, and it will then load that component for us. If I pass null, it won't do that. We can always just do something kind of hokey and just say like loading LOL, and an H1 is our fantastic loading component. I always like doing stuff like that. And then it has a prop called persister that will be the one we configured and created and exported out from our store directory. Beautiful. Okay, that honestly should be all we need to get this sucker up and running, as simple as it can be. Do I have any errors first off? It seems like it's built fine. But, you know, that's yeah, there's the error I was talking about. So this is an error that you're going to be getting from redux-toolkit's, you know, like error handling, linting, whatever you want to call it. It's telling us that a non-serializable value was detected in an action in the path register. And that's a path coming from type persist, which, surprise, surprise, is coming from the redux-persist action type, right? So it's looking at it and it's saying there seems to be something off in the value here being passed in that says, hey, this is not serializable, so I don't think it's safe to put as redux state, and that's what the error is telling you. So even though you have this error, if we head over to our, zooming in on this makes it so awful. Yeah, it looks like it's firing off some actions here, and persist says, okay, just save this state, and rehydrate means, oh, use this state in our React Redux application. So it's saying rehydrate with this value, actions payload. Look at that. This right here, if you watch the previous two videos, you know is my state structure. So it took the default state values, and I believe it's already saved them, and it adds its own little key to the state as well, so it can track like versioning and whether it's been rehydrated or not and things like that. So it adds some information about itself there. If we head over to the console log and clear this error out, we'll deal with that in a minute. Zoom back in so I can see, and if I hit local storage. If you check it out, it has indeed, well, it serialized it and put it in local storage. So it's already working out of the box. So if I do a couple counts, maybe we do a login, that's working just fine in Redux Toolkit here, or Redux DevTools. And if I hit a hard refresh, it indeed persisted everything that it needed to do. So that's pretty cool that we got up and running in almost no time whatsoever. So getting rid of this error means we need to tell our configured Redux toolkit store to ignore certain actions. That way the action can fire and we won't see this big fat red error here. Because even though we get the error, I mean, clearly it's still working, as every time I refresh, like I said, it remembers what I did. So it is correctly persisting and hydrating our store with local storage. So maybe that's the solution you're looking for and you don't even care about the API part, in which case, congrats, I learned something new. Okay, so how do we do that? This is something else I also touch upon in the course, in my React course about Redux Toolkit and how to configure custom middleware on it. We're going to add some properties to our configure store object, including our one called middleware, where it has a function that gets the current list of middleware. Because if I tell it, hey, use my lol middleware or something like that, it is simply going to override all current middleware. So I need to somehow get the current list of middlewares, and that's where this function call comes into play. So what it's going to actually do is take an argument that we can call this get default middleware, will be the function that allows us to, well, get a list of middleware. And then from there, we are going to simply call it, and it took an object argument here. And this object argument will take takes a property called serializable check. It's going to be an object, and it has a property called ignored actions, right? We can say ignored actions needs an array of the actions to ignore. So where are we going to find these actions? Well, like I said, we know that actions are just JavaScript objects with a type and payload property, and thankfully they have exported the actions out from redux-persist for us to use. So they are called flush, flush, stop it, rehydrate, pause, because you can actually pause this whole process here. Like, again, I mean, the library itself is pretty cool. I've like barely scraped the surface of everything it can do, other than trying to find out exactly how I can help my students as fast as possible. So actually, maybe, if there's interest, please get in our Discord, let me know, or get in the comments below this video and say, hey, do some more deep dive on some of the features on Redux-persist, and I'll be happy to make that content, because again, I get to learn something new as well. So there we go. We just pass in that list of action types, or the action objects, into our ignored actions. So now we've configured our store. We have maintained our current list of middleware, and we haven't overridden them by mistake or something like that. And we've learned something new about being able to ignore certain actions. And as you can see, the error is now gone and it works as it should. And so this is how you actually configure it with Redux Toolkit. And I believe even Redux Toolkit's documentation shows us an example of how this could look like according to them. So like they even have like a tidbit in their own documentation about Redux-persist and how it looks with the toolkit setup, which is where I learned the technique from, right? Okay, so it's all well and done when we have it working with local storage. But again, the student's question was, they're building a game. I'm sending this to an API, aka this goofy little server I have running here. I might as well open Postman for some testing if I need to, right? Remember, it was, again, from the first videos where I talk more about this, it was nothing more than a endpoint to send some state to our server, and it responds with the magic phrase of state saved, and I can retrieve that state when needed, right? So clearly the students particular project has a bit more complexity than this, meaning they have to like take someone's JSON web token and then retrieve their state, because they want to make sure we retrieve that individual's or user state and not just anyone's state. So my server is hella simple, but it gets the job done, and it just gets the logic ball rolling, and then y'all can take and keep building and adding features to your projects with this logic. So, okay. I talked about from their documentation that you can pass a custom object wherever the heck it went. Now this is back at the top here. You can pass a custom object as storage, so we can write an object here as long as it had those three properties on it, right? I'm going to make this an individual file since all these files are already getting kind of clunky, so I'll call it something like API storage, maybe. That's a cool name. API storage.js. Export const API storage equals curly braces, voila. And like I had mentioned, it simply needed those 3 keys and values, right? So we had get item, and I know they're going to be object or functions rather. We had set item, and then we had remove item. Okay. Now there's no documentation about what these functions do. So like I said, I've been poking around in node modules, poked around in their GitHub source code, looked at how they wrote their storage, right? Like I was curious as to how they did it. So I ended up just poking around in their source code. I found that storage directory, the same one we're getting storage from. That's where, yeah, that defaults to local storage. Where'd you go? Create web storage, yish. And this is where I ended up finding how it was actually set up themselves in order for me to figure out how to write my own, right? So here is where indeed they are using functions that have these arguments called a key, and that key ends up being what we were looking at in local storage of our app here. All right, this persist : primary part is the key they're storing it under, and that is what the key argument ends up being. And in the set item code, the item ends up being, well, the entire state it's trying to save or what it's set in there. So that's all it ends up doing. They all return promises. You don't have to return a value out of them. They just have to simply resolve a promise. That way they can work asynchronously. And that's why this library can get the job done by calling things to an API. So just out of curiosity, we may not actually end up using the keys in any way. I mean, you probably should in a full, like in my student's application, that game he's building, the key might be something he stores like in his SQL, or I think Mongo database is what he's using, MongoDB. He might be using the key to, you know, however he needs to. But in our case, we're actually going to end up not using it. But nevertheless, I'm simply curious. So when I was doing this, I did the classic debugging step of when do these things actually fire off and when we use them, right? So we should have one for remove item. I'm gonna leave it there, but I ended up not using it because this demo is not going to be purging or removing or resetting anything from state. So I'm not really worried about adding code for remove item because we won't be using it in this demo. I was simply curious as when these actions fired. So now that I have these functions queued up with some console logs, it's clearly not going to persist anything, but at least now I can choose to import my own storage. Import API storage from the API storage file, and we're going to be using API storage in place of that. So all we've done now is simply swap some things around, and let's see what the console logs tell us. Here we go. All right. So it got mad because my set item did not return a promise that had anything it could do, and it looks like it just ran some code and tried to handle a promise, error handle, all that kind of fun stuff happening. Either way, check it out. We got some console logs going. So clearly it tries to run get item first, and when the state changes, it runs set item, or rather when the app crashes. And the key is indeed what we were talking about, what happens to appear in local storage, persist : root. All right, so that's pretty cool. At the moment, I have no state. Well, every time I save this application, my server restarts because it's poorly. I mean, this is not how I'd run a project, but this server ends up restarting every time I change code over here. So whatever I send to my server in Postman, if I change any code here, it's going to crash. So check this out. Let's rather than using .then syntax, let's make this an asynchronous function. Like I said, it can handle promises. Let's throw in a try catch. And we're going to say, just throw this error up the chain, and I'm sure some error handling in its system in the code for, actually I just throw the same error again, I'm gonna make a new one. It'll just throw the error from the catch, and that way, whatever ends up happening somewhere in the persist code, that hopefully that error handling ends up occurring the correct fashion. And over here, let's just keep it simple, right? We can say const res equals await a fetch request, a fetch get request to /state. No options required for the fetch request. This data comes back to us in a response. And again, if you need to do some error handling, because again, my students always say, well, how do that works, but what happens if X isn't there? So again, I tell my students in our course that next step of becoming something a little bit more than a junior dev is automatically thinking of edge cases in your code. And especially learning TypeScript like you do in our full stack curriculum, you get pretty good at thinking of edge cases because you have to add type guards everywhere. We can just say request failed or something like that if we get a bad status code. So as an example for you students who are asking about that. Otherwise, so here's something I learned the hard way, where the response is, well, a response object that has a body on it, and then it has several promise functions that can convert the data over. So we're basically parsing this JSON data, and here's where I thought, okay, well, if I return the data, that means it's returned, the promises are resolved, we return this data from this function, and get item should be able to hydrate our store like we expect it to, right? So we have no state saved, so let me go to my Postman, send this. So now I have a login of true and a value count of 10, which means if I refresh, it didn't seem to get the state correctly. I remember poking around in my Redux dev tools and wondering why it was coming up short with our state stuff here. I don't know why the window is being weird there, right? I'm like, that is very peculiar, because if I go back to Postman and get my state, it indeed gets back the correct state values of true and 10. So why is not returning the state to my persister working the way I expect? That is because, and I found this out the hard way, that you need to return a serialized version of your state and not the raw JavaScript. I parse this JSON into JavaScript, and if I want it to work, I have to do that. Now, how did I end up learning this fact? Because it's not in the docs. Well, that's because I looked at someone else's library. I think it was redux-persist RESTful storage, and I looked through their compiled code in their repo to see what they did differently compared to me, and then I realized what it was, which is indeed they JSON stringified the data and sent it that way. So let's post this to Postman, get my state saved, refresh the window, and it still failed. I'm guessing it's because it can't set the persisted state and then get it, so hold on, I think I need to code out both. Obviously, this is clearly a first run for me in this recording, and I know this code should ultimately work, and I don't think I'm forgetting something dumb like I tend to, but I think I also have to have set item coded out, because clearly when I was coding this, I had both coded out at the same time to get into post, for example. So let's see if I code this out, if it ends up working the way I think it does, right? So let's try that instead. Let's yeah, I'm going to copy and paste this request, this try catch block, into set item. It's going to be surprise, surprise, and await fetch request to /state. Here's where my method needs to be a paste request, evidently. Pops, can't type today. Headers, content type. I don't think a single thing has gone right in these videos the first time around, but you know what, folks? That's fine. That's just how things work, right? And I also learned this the hard way, that the state it gives you, aka the item to be set to whatever storage you're using, is also already serialized, so I do not need to JSON stringify this item property, this item argument, because it's already serialized to be stored somewhere in some form or fashion, right? So there we go. We have sent that to our server. Same thing, if the response is bad, then whatever. And then for return value, it doesn't really matter what we do, and I don't really care about logging the server response. I can just return like whatever string I want, or just return end of function, because nothing needs to happen. I mean, it can be like a return void. That's totally fine. All right. Okay, so let's see if that is now happy with me, since I got the code correctly written out. It is not happy at all. Unexpected reserve word await. Okay, that's because I forgot. I'm dumb, y'all. Get in the comments if you saw what the error was. I forgot the keyword async. It's always something. Right, so no errors now. I've changed the state around a little bit, and if I slow it up and I refresh it, voila. Let's go look over in Postman and see what the state looks like when I make a GET request, to make sure I'm not, no cards up my sleeve tricking y'all, fooling y'all somehow. And yeah, that's why, because it persists it sends it as like this serialized state that's not exactly JSON. It kind of serializes it. Well, I mean, it's a string, right? So that's all it is. But it serializes it in a particular way, and has that key of _persist, which is probably why my JSON test wasn't working here, because I didn't include that extra. I forgot about this property, even though I talked about it earlier in this video. And that way it's like, oh, I don't know. So it's defaulted to the original state. So that's probably why it didn't work for my Postman test. But either way, I've got it working now, and voila, right? I'm not using the key, which is, again, you probably use that in your actual application. I was trying to show y'all the logic of how it would work to create your own storage object to make it persist with an API. How fantastic! So guess what? No matter what I do, it will persist it. And I don't know if you saw the flicker of the loading right there. How can I make this? Yeah, I got it. Check it out. I can go to my server and I can show you all that loading state is actually doing something by taking this code and just wrapping it in a dumb little set timeout and say, hey, take like 2 seconds to resolve this response before you send the state over. So that way, if I hard refresh, everything's going to be, see, you can see that it's trying to persist that information from the server. And because I made my server fakey slow, it takes a second, and you can see that loading prop of that persist gate component kicks on like a beauty. So there you go. If you need to code your own loading component in some form or fashion, you can just pass it right to that prop and you're good to go, folks. We are persisting to an API with redux-persist. And it took me some agonizing amount of time to figure out how to properly do it. So I hope y'all enjoyed this video and got something from it. If you have questions, get in the comments below. As always, this is a playlist in this series, so go check out the previous videos. Check the description below for a link to Covalence, information on how to sign up for one of my React course or our full stack course if you're interested in learning how to do that stuff. At the very least, join our community, get in Discord, ask questions, get in the comments, and make sure to like, comment, subscribe. So this is Luke signing off in this series. Bye.